Hello everyone, I'm teacher Winnie. Today we'll discuss on Physics SPM Trial 2022 for Pahang paper 2. First questions is regarding on this photoelectric effect on combined last chapter on quantum physics. Diagram 1 shows light rays at a certain frequency illuminated on a metal surface. Electrons are emitted from the metal surface. Mark with tick for the correct answer in the box provided. So as you can see, when this light, and actually this is referred to photon, strike on the surface, and the surface of the metal will have a lot of electron, and the electron is being emitted out, as you can see from the diagram. So this phenomenon is known as photoelectric effect. Now, what is thermionic emission? Thermionic emission is the release of electron from heated metal. So if there is a metal surface like a filament, when you heat up, then the electron emitted, then this is called thermionic emission. But for this case, we call it as photoelectric effect. Next, B. Name the minimum frequency that allows the electron to be emitted from the metal surface when light is illuminated. So from the idea of photoelectric effect, when this photon energy strike on the surface, they must reach certain frequency. And this frequency is what we known as threshold frequency. Threshold frequency, where this is the minimum frequency required for the electron to be emitted out. Now, let's say the frequency is lower than the threshold frequency of the metal. That means there will be no photoelectric effect occurs. So normally, in order for photoelectric effect to occur, you must have light with high frequency, whereby they should have low wavelength. Example like violet, like red color, normally their wavelength is very long, hence the frequency is low. So normally we can't see the photoelectric effect if you use the light source like red. Now, C1, what will happen to the kinetic energy of electron when intensity of light increases? So for this case, they will be unchanged because the intensity of light will not affect the kinetic energy of the electron. So from the topic or Einstein of these photoelectric equations, you will notice that they have this relationship whereby the energy, the photon energy is equivalent to work function plus the kinetic energy. And from this photon energy, it's actually come from the idea of this Planck frequency, Planck constant multiplied with the frequency itself. So therefore, the frequency will only affect the kinetic energy of the electron and not intensity. Now, what will actually affected by the intensity of light is basically the number of electrons, which means when they have photoelectron effect cause, if you shine even more lights, then what happens is more electron is being emitted out, but it won't change the kinetic energy of the electrons. Okay, so hence this is the explanation. You can say the kinetic energy of the electron is not affected by the intensity of light, or you can say the kinetic energy of electron is affected by frequency only. Okay, then we proceed. For question 2 is come from the four topics wave on the idea of electromagnetic wave. So figure 2 show a radio wave used by a television broadcasting station for a local broadcasting. And the emitted wave can be detected by the receiver of the wave signal. State one characteristic of radio wave. So generally, this radio wave is come from the 7 electromagnetic wave. If you also remember, start with radio, then micro, then you have infrared, then you have visible light, and then ultraviolet, then X-ray, and also gamma ray. So generally, all these 7 waves, they will have the common characteristics. So any of the common characteristic basically can be used as the answer. So one of the example is they travel at speed of light, and they can travel through vacuum, right? If you want to be more specific for radio wave itself, okay, radio wave have the longest wavelength. So you can also mention this, or they have the lowest frequency other than all the 6 idea that I show here, okay, whereby radio wave is a transverse wave, does not require a propagation medium, can travel through a vacuum at the speed of light, propagate with the speed of light. You didn't mention the value is okay. Then show the property of wave like reflection, refraction, diffraction, and interference, and also obey the wave formula. And all these answers also applicable for the other 6 waves that I showed just now. Next one. The frequency of the radio wave emitted is 2.5 times 10 power 8 hertz. Calculate the wavelength of the wave of the radio wave. So generally, given you frequency, they want you to calculate the wavelength, and just not to mention the speed is generally the speed of light, which is 3 times 10 power 8. So therefore, you can apply the wave formula, which is V equals to F lambda, and rearrange lambda equals to V over F, and this V is actually C also, 3 times 10 power of 8, then divide by 2.5 times 10 power 8. So whenever you use this formula, okay, since you divide something multiply, right? So it is advisable to bracket it, or else your answer will be different. Okay, so hence you will have the answer of 1.2 meter. Make sure your answer must come with unit, and the unit for wavelength is meter. C. Radio wave transmission from television broadcasting station in diagram 2 is blocked by hill and or tall buildings. The wave can still be received by the receiver of the wave signal. Name the wave phenomenon involved and explain why. So since there is a lot of hill, there's a lot of tall building. So when the wave traveling, so basically what will happen is the wave there pass or around an obstacle. Notice not or barrier. So therefore the wave basically will spread. So this idea or this phenomenon is actually known as diffraction. So when the wave spread out, right, that's why they still able to receive by the receiver, because they're basically bent around, okay, or scattered after passing through a small opening or around a barrier. Okay, next, question 3. Question 3 is from Form 4, gravitation on Kepler's law. So diagram 3 shows a planet revolve around the sun in an orbit, and the time taken from P to Q is equal to the time from R to S. And the area of these are OPQ, and also the area of this ORS is equal as well, equal. Okay, so what is this law? So this is basically Kepler second law, Kepler second law. Okay, next, B1, mark with tick for the correct statement. Okay, so basically, which part the speed is greater? Okay, so basically they mentioned that the distance RS from here to here, I assume S1, and here to here S2, right? They will take the same time to travel. But as you can see, the distance is different. So how do we relate the idea of this speed with distance? Speed is also equivalent to what? Distance over time. Since S2 is greater than S1, right? So assuming this is S2. So that means S2 is much more greater, but this time is constant. That means same for both, which means your speed on part 2 will also be greater. Therefore, the linear speed from P to Q is more than RS. Okay, so basically, if you want to look at the animation where how the planets actually orbiting the sun, when you click YouTube, you can actually see the planet. Basically, they will just move around. They will move around, and whenever they actually reach nearer to the sun, right, they will travel faster, then they will slow down. When they are further away, then they faster again, they will further, then they faster again, they will further, then slow down, then faster, slow down, faster. Yeah, so the reason is like I mentioned, due to the distance, PQ is longer than RS. C. Calculate the orbital period of the planets in hour, if the average distance from the center of the sun to the orbit is 1.5 10 times 10 to the power of 11 meter, and the mass of the sun is 1.99 times 10 power of 30 kg. So what formula can you apply for this part? So actually, this formula is used to derive the relationship of Kepler's second law, whereby you have this T square is directly proportional to R cube, or is actually one of the formula that you rearrange, you can find the mass of the sun or this mass of the earth, right? So you actually can derive out this formula whereby the gravitational of universal is equivalent to the centripetal force. So the gravitational universal gravitation, the formula Gm m over r square equals to mv square over r, this centripetal force. Then what you do with this formula, the small m, mass of the planet lah, you can cancel out. And then this r, you also can cancel out 1. Hence, you have G capital M, which is mass of sun, okay, over r equals to v square. Then next step is, you should know that a linear speed, you can also be calculated by using the radius of a circle, which is 2 pi r over the time taken for one cycle period. And then you sub into this equation. Then you expand it. You will have 4 pi square r square over t square. Then this r you bring up, right? So that means it becomes cube later on, right? And then this T2 I swap with the GM. Hence, you will have this relationship r cube. You will have t square equals to 4 pi square over GM, this whole thing bracket, then you have r cube, whereby this 4 pi square over GM is actually a constant. And this is where they tell you the relationship of Kepler's second law. Okay, so basically, sorry, this is not Kepler's second law, this is Kepler's third law. So for Kepler's third law, right, the idea is basically you have any planets orbiting the sun. So if they are getting further and further, that means their time taken will be also longer. Yeah, so this is the idea of Kepler's third law. Okay, so sorry for the beginning, I mentioned the idea wrongly. So basically, example, this is R1, then your time for T1 will be shorter, and then followed by R2, then T2 will be longer. Then lastly, of course, if you are further from the sun, that means this R3 will be the greatest, right? That means T2 is also the longest. Yeah, of course, we will use this formula for calculation now. Okay, so if you were to sub everything correctly into the equation, like just now teacher show, t square equals to 4 pi square over GM, then whole thing times with r cube. So the pi, you can use the pi in calculator. The r itself is 1.5 times 10 power 11, then the whole thing you cube it, divide by g. G is the gravitational constant. Now, where can you get this value? Basically, you can get this value from the formula list, and then m is the mass of sun. So when you sub everything, remember this bottom one, you whole thing have to bracket. Then at the end, you will get the answer, but it's still in t square, you know. So you have to get t by square root of the whole answer that you get. And then at the end, you have to change to hour, in hour, by dividing 3,600. So hence, you will get the answer of 8,800.85 hours. So the value of G is 6.67 times 10 power of negative 11. Okay, so because there will be a lot of square cube, so whenever you solve any question involving the topic under gravitation, it's good that you actually press your calculator a few times to avoid any mistake done. Okay, next questions is from 5 topic for this idea on gas pressure, chapter 2 pressure. Diagram 4 show an instrument which is used to measure the gas pressure. Name the instrument in diagram 4. So this YouTube thing, the actual name is called manometer. Next, compare the gas pressure in the flash with the atmospheric pressure. So the gas pressure is over left-hand side lah, right? While the atmospheric pressure is on the right-hand side. So if you look at this tube, this one being compressed so much, right? That means your gas pressure will be what? Higher. Yes, it will be greater. Yes, so therefore gas pressure is higher than the atmospheric pressure. Okay, state the difference between the gas pressure and the atmospheric pressure in meter H2O. So under this topic, of course, generally the SI unit for pressure is Pascal or short form PA or Newton per meter square. But then in other contexts like in water dam, normally they will have the unit as meter H2O. And then if you were to measure your pressure, blood pressure, so normally they will be in millimeter mercury. Yeah. So because you're using different liquid, hence they will always have this. But this is another idea of the unit of pressure. So state the difference between the gas pressure and atmospheric pressure. So that means they want this length, but they are in meter. So now you have 36 cm, right? So change 36 cm to meter. Hence you will get what? 0.36. And then next, they want you to calculate the gas pressure. Okay, so how do you calculate the gas pressure? Okay, so generally, first step, you're supposed to draw a line between the boundary of this gas and also the liquid. Then the next idea is same level, same pressure. So this is the idea behind it. Same level, same pressure. Also, that means the pressure on point 1 supposedly equals to the pressure on point 2 lah. And then you look at the diagram. Point 1 is actually acted by what pressure? Gas pressure. While pressure 2.2, you have a column of liquid, right? And then on top of it, you have this atmospheric pressure. So hence you have this liquid pressure plus atmospheric pressure. So hence, in terms of the length in meter, this liquid pressure itself is 0.36. And they also tell you the atmospheric pressure is 10.3. That's why you have this relationship. And you get this 10.66 meter H2O. Okay, next, how you actually can change the idea to become Pascal. Basically, you will use the liquid pressure formula, which is H rho G. And this H is referred to the length in meter. And then this rho is referred to density of the liquid. And G is standard 9.81. Yeah, so for part 3, how you calculate, like I told you just now, the length is 10.66. Then you time with the density of water. Then G 9.81, hence you get this in Pascal. D, water in the instrument in diagram 4 is replaced with mercury. What happened to the difference in the liquid level? Explain. Okay, so basically, the gas here, they won't change in the pressure one, right? So hence, the gas pressure generally will be constant. So based on the formula P equals to H rho G. Since water is 1000, the density of water is 1000, and basically density of mercury is very high, of course, compared to density of water. So their value is 13,600. Okay, since G is also a constant value, P have to be constant also, right? And this density now become mercury, so it means greater. So what happened to the value of the length? They have to be shorter or decreased in order to have the same gas pressure. Also, here is your answer, decrease, and density of mercury is higher than water. Number 5. Okay, number 5, number 6 is comparison questions. And this question 5 come from 5 topic on electromagnetism on this force on a current carrying conductor. Diagram 5.1a show a magnet placed in an electronic scale, and XY conductor with a current of 5 ampere is placed between the magnetic pole, while 5.1b show a similar equipment and arrangement where the value of current passing through the conductor XY is now 10 ampere greater current. Okay, first, what is the rules that used to determine the direction of force? Okay, so if you all should remember, teacher always mention in order for you to remember left or right, okay, we refer to the application, right? Either 4.1 under motor idea, dynamo is under 4.2 electromagnetic induction idea. So if you see the instrument got current, all this, you will use Fleming what? Left. Because the motor location at the more located at left. If it is a vice versa idea, that means you cause current to produce induced current, then you are using the Fleming right in order for you to determine the direction of induced current. So for this context, you are using Fleming left-hand rule. Okay, based on 5.1a and 5.1b, compare the value of current passing through XY. So this one direct, they already tell you the magnitude, which is 5 ampere and 10 ampere. Of course, 5.1a is less or vice versa. Okay, then the reading of balance, they also show over here 0.02 and 0.04. So when you are comparing, you are not stating the value, you just mention which one higher or lower will do. So the reading of electronic balance is 5.1a is less than 5.1b. Okay, and I always tell students, make sure you all really write the full terms. What is that? You don't just write 5.1 more than or less than 5.1b like that enough. Or you give full terms. Then the magnitude of force. So since the current is greater, okay, the weight is greater, of course, the force produced is greater for B, but less for A. Also, this is the way how you write. You can use the symbol bigger, smaller, or you can use the term greater, smaller. And normally, this will bring to the relationship question later on. So based on your answer now, state the relationship. So as you can see, everything in 5.1 is smaller, right? So you can have the relationship when the current increases, the electronic balance reading also increases, or you can use the term directly proportional. Okay, same go for part 2. Deduce the relationship between current and force. So same thing, the greater the value of current, the greater the magnitude of force. And then predict if you were to use a thicker wire. If you use thicker wire, that's mean more current able to pass through due to low resistance, right? And the force will be greater. Yeah, so your prediction, you can write greater or increases. Okay, moving on. So this is a cross-section view of the conductor and two magnets with different poles. Okay, so basically, this cross means the current will move into. Okay, so basically, how do you complete the catapult field? Okay, so you can apply your Fleming left-hand rule. Okay, let's say you don't know how to use. So basically, first, you make sure you use the correct hand, left hands. Then this thumb is force. B is magnetic field, I is current. So current into, that means you point away from yourself, that means into the screen. Like now you are looking at the video, right? Yes. Okay, or you have any worksheet, that means you point into your paper. Then this finger north to south, or they always point towards north to south. So that means I need to point to the left side. So how do I rotate? But I don't change the direction of current. I only can do like that. So hence I rotate this way. So where is your thumb? Your thumb is basically upward, right? Yes. So the force produced is actually upwards. Now, based on the concept of this catapult field, why the force or the wire move upward or the conductor move upward is basically uneven magnetic field, where this field is due to the strongest field to the weakest field. Hence, the bottom one should have more lines. Minimum of trigger, but then top one you just need to draw at least one or two will do. Yeah, then north to south, this arrowhead. So this is what we call as catapult field. Okay, next questions, still under comparison question is under elasticity for 5 chapter 1. Diagram 6.1 show the graph of force against extension for spring P and Q. Okay, what is the meaning of elasticity? So meaning of elasticity, the ability of material to return to its original shape or size after the force acting on it is removed. Then next, they want you to calculate the spring constant. So the formula for spring constant will be K equals to F over X. So this graph is force versus extension, and you can basically find the spring constant by finding the gradient of the graph, or you can relate gradient of the graph with this spring constant. So since they want for P, that's why you find the gradient of P. So you will use 60 divided by 0.6. Yeah. And the unit is Newton per meter. Now, let's say just to be take notes, if you would to look at the graph, this one, they are in SI unit. Sometimes question will give the unit in terms of centimeter. So it is advisable to change to meter, because sometimes they will also ask you all to calculate the elastic potential energy. So just now teacher mentioned spring constant is calculated using gradient, right? Now, generally, the elastic potential energy is area under the graph, area under the graph. And commonly, we will use joule as the unit for energy, right? Yeah, so therefore, another unit would be Newton meter. So if you don't change cm to meter, sometime you will have the wrong answer lah. So that's why bear in mind, if possible, change everything to SI unit. Okay, again, comparison question. Based on 6.1, 6.2, compare the thickness of spring wire P and Q. So based on this diagram, obviously, who is thicker? Spring P is thicker. Then you just say, look, spring P is thicker. Then extension-wise, you see, since they are thicker, that means it's harder to extend, correct or not? So their extension also less for P, or whatever side you say Q is longer. And spring constant can be related to the stiffness of the spring. If the spring very stiff, that means very hard to stretch. That means their spring constant is also higher. So hence, spring P will have higher spring constant. So this is the way how you write the answer. Yeah, or you can use the greater sign again. Or you say spring P is thicker than Q. Then extension of spring Q is longer. Spring constant for spring P is higher. Okay, then we move on to the relationship questions again. What is the relationship between thickness and also extension? Of course, thicker wire, less extension, or you can use the term inversely proportional. Okay, thicker wire, shorter extension, then spring constant. The thicker the wire, the higher the spring constant, or directly proportional. So what is the law that explain the idea here? This law is called Hooke's law. Make sure you spell correctly, because any wrong spelling, you will get 0 straight away. for laws. Okay, move on. So for question 7, this question now is on the idea for electronic topic, transistor. Diagram 7.1 show a transistor circuit act as current amplifier. So what type of transistor in diagram 7? So this is the symbol of transistor, and you have two types of transistor that we call it PNP or NPN transistor. So how do we identify is you look at the arrowhead on the emitter leg. So basically they have 3 legs. You have base, you have collector, emitter. Okay, then next, how does the flow of current? Current is always flow from positive terminal to negative terminal, correct? So base will actually different from the other 2 sides. Okay, hence this is NPN transistor. Okay. Then under this transistor topic, you should know that transistor have 2 functions. One, they act as current amplifier, like what this circuit shown. Another one is they act as automatic switch. So for automatic switch will be come later on these questions. Simple idea, as you can see, transistor have 3 legs. Since they have 3 legs, right, they can have more than 1 circuit. Instead of like if you only have battery 2 legs, then you have 1 circuit, right? Like bulb, yes, or diode, they only have 2 legs, right? So that's why they can only have 1 circuit like that. But then transistor, they always have 2 circuit. So the circuit with the leg of base and emitter, you call them as base circuit. This one, CE, we call it as collector circuit in short. So therefore, this is the IB, is called base current. IC is called collector current. Now they want you to change the current in terms of microampere into milliampere. Of course, first step you need to know this micro is referred to 10⁻⁶. Micro is 10⁻⁶. Then milli is 10⁻3. So which means I need to split them into one, which is 10⁻3 on milli. That means they will left 10⁻3, right? Yeah, so this one you change to become milli. So of course, 100 times 10⁻3 is not the correct standard form, right? So either you write in a whole number, which you change it to become 0.1 milliampere, or you can write 1 times 10⁻⁻1 milliampere. Now, how come these questions actually ask you all to change it to milliampere? Now on part 2, they ask you all to calculate the amplifications factor, where the symbol is beta, right? It's actually IC over IV. So your collector current is actually in terms of milliampere. Okay, so they have 5 milliampere. So you have 5 milliampere divided by 0.1 or 1 times 10⁻⁻1, right? So you can cut off, hence you have 50. There is no unit for amplification factor. So you basically amplify the current, see 50 times. Yeah, so a small base current can cause a large collector current to flow. Okay, again, the schema wrong, you shouldn't have unit over here. Now, but let's say, if let's say you try other questions again and they ask you to calculate the amplification factor, and they didn't ask you to change your microampere to milliampere. So let's say they just asked, what is the amplification factor? So IC over IB, right? Now, basically, you can just straight away write 5 times 10⁻⁻3. I always tell students change the milli to become 10⁻3. Then micro, 10⁻6, right? Then this whole thing, you just straight away divide, you will still get 50 times. Because after all, you cancel out your ampere. Okay, so this is more easier in order for you, you just need to change 1 unit and then sub again. Okay, now this is another pattern of the circuit where this transistor now act as what? Automatic switch now. So the teacher's room at the school will be equipped with the air conditioning amp. The proposed circuit is as shown in this diagram. And it was found that the air conditioner amp that was installed did not work well to cool the teacher's room. Still, the modification that need to be done to ensure that the air conditioner can work properly and more efficiently. Okay, so basically they want you to state what type of transistor is that and where should you place your thermistor. Okay, so as you can see, P and Q, they are act as automatic switch patterns punya circuit. One of the resistors should be the fixed resistor, while the other resistor is some special type of resistor where either they're sensitive to heat or sensitive to light. So if they're sensitive to heat, then we call it as thermistor. So always bear in mind their character. This is a very important. So when do they have high resistance or low resistance? So for thermistor, since they are sensitive to heat, so they will have two conditions, hot and cold. If the temperature is hot, the resistance will be low. While if the temperature is cold, that means the resistance will be very high. Okay, so how the transistor circuit able to work? Again, you need to look at the base part. So normally at the bottom here is called base circuit. So I will tell students, to make your life easier, you always remember if base is working, everything is working. So how do you know base circuit is working? So you have to look at the resistance. The resistance on the base must be very high. So when the resistance of base is very high, it will cause the base voltage to be greater because you will have a formula that relate resistance with voltage across it, and it called potential divider formula. So their relationship is directly proportional. Then only you look at how the voltage affect the current. So when base voltage is high, then base current can flow. Then everything can be function. Okay, so and what is the relationship between P and Q? Since they call it as potential divider. So the idea will be if the resistance over here high, that means the resistance over here will be low or vice versa. Okay, since I already say I want base to be high, if I want this to be high, that means the top one must be low. So when does you want the aircon to be function? When the temperature is very hot, right? So which means when it's hot, the resistance is low, so you have to place it on top, yeah, so then you have the condition of low resistance causing the base circuit to have high resistance. Okay, or in general, like fire alarm system, right? You want it to be function, you have to place the thermistor on top. Then only they're able to detect heat, and then they show low resistance, then causing the base circuit to be high. Then everything is working. Okay, so therefore your position will be at P. Okay, then next they will actually ask what is the transistor over here. So for this part, then you look at the direction of current flow. This negative terminal, positive terminal. So of course, current will flow from positive, right? So in order for the arrowhead over this emitter leg, right, to go downhill, then only it can go backward. Agree? So since it's go downhill, you see, just now teacher teach you how to identify NPN and PNP, right? So positive to negative, hence you're supposed to be NPN transistor. So it seems like you have the correct circuit already. So for this type of question, again, is similar like essay part. The moment you choose correctly, you already get 3 marks out of 5 marks. And of course, you need to write the correct way. So like you say, where is the position? You say is at P. Reason, like say, when the temperature is high, the resistance of the thermistor decrease at P, understand? Hence, it causing the base voltage to be larger at part Q. Then type of transistor, NPN, so that the collector current can flow out or transistor can be activated. And hence, lastly, you write the correct choice, which is L. Okay, then the last structured questions is underlined on the last topic on mirror. So diagram 8.1 show an image of why mirror placed in a corner of the top of the shop for security to assist the shopkeeper to monitor the safety in his shop. What light phenomenon involved in mirror? Why? Okay, so of course mirror, you have the concept of reflections. Yeah. Okay, then next, Diagram 8.2 show an incomplete rays diagram of mirror Y, and C is the center curvature of, and F is the focal point, and complete the ray diagram. So every time when you draw ray diagram, I always tell students, you must really identify, is this a mirror or lens? So what mirror is this? Okay, so generally that curve outwards. So if they curve outward, you call it as convex mirror. Then what phenomenon just now we already say, is the ray will reflect one. Then next idea that is super important is you need to know that whether the ray is diverging or they are focused converging. Okay, so for the convex mirror, it is more makes sense. What do you think? The ray will actually go uphill like that, diverge, or they will focus? It will actually go uphill like that, which means they are diverging. Yes. So this is a very important idea. The ray will diverge after the phenomenons. Okay. So now if they diverge, your reference point will use the virtual focus point, which is on the right-hand side. So you will draw dotted line, then you strike out. That means the ray will bounce after they strike this surface. And then the next one is this point and this point, it's going to cut C. But then upon they touch a mirror, they bounce back. So same thing when you goes. Okay, but then why it should be dotted? Because it's not supposed to exist. But you want to know where is the location of the image, right? So hence you still need to draw this ray. Do you notice you have the intersection point over here? Yeah, this is where the image form. Okay, label I. I put error on this object. Yes. So if you compare the image to the object, they are basically diminished, notice, and then they are upright and they are virtual because they're formed by a virtual point. So this is a characteristic. Now it is good that if you know how to draw the arrowhead, like I say for the first one, the green one, right? They strike, they bounce, so the arrow go up, and then for the ray that you cut C, right, center of curvature, they will bounce back on its own path. So that's why you will have two arrows over here, lah. But in exam, you really not sure where to dotted or clear line, then you draw everything clear line, right? But no dotted at all. But you know, then you draw the correct one. Okay, move on. The shopkeeper found out that it's difficult to observe the activity in his shop. Suggest modification to the mirror based on the following aspect. What type of mirror, the radius of curvature, and the diameter. Okay, so first, you will use a convex mirror. Reason to produce upright image. Okay, because if you have concave mirror can have 6 different characteristics. Whereby if you were to place your object at different position, like less than focus point, between F and C, right? Then you may have a inverted image, okay? Or memang convex mirror, their main idea is to widen the field of vision. So you can still write this idea, widen the field of vision. Okay, then next one. What is mean by radius of curvature? Radius of curvature is actually the distance from the center to the curved surface. That one is called radius of curvature, this one. Okay, that means if I were to have a bigger circle, then you will have this point C and F further, agree? Yeah. So if you will have this point of C even further, greater, big, then when you find your intersection point later on, okay, we go back to the previous page, then you will have better pictures on that. Okay, so teacher show, like I mentioned, you have a further point of C, correct? Okay, so your F also greater lah. Okay, so again, we will assume the object is still on the same position. Now, teacher just redraw. Okay, you strike, then your F is over here. Then your C is where? Okay, you look, where is your intersection point? Somewhere here, right? So it means you will have a bigger one compared to this one. Notice? But of course, you compare to object, this image is still called diminished. So that's why here they reduce they write there to produce a larger image. This is what it means. Then diameter, of course, this curvature part also big. So same thing lah. You have a widen the field of vision. Yes, hence we actually finished the part for the structured. So we'll proceed to the essay part. Okay, for essay questions is under Form 4 topic chapter 2 on momentum. So diagram 9.1 show Falcon 9 rocket is launched from a launch pad. What is the meaning of momentum? So of course, common definitions. So momentum is basically the product of mass and velocity. Any object that have mass and have velocity, they will have momentum. Okay, next one. Explain how the release of hot gases through the rocket exhaust enable the rocket to accelerate upwards. So based on principle of conservation of momentum, there are 3 types of collisions, right? So most of the application is under the idea of explosion. So based on the general formula, you have M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Okay, so this is the idea of principle whereby they say the total momentum before the collision must be same as the total momentum after the collision. So under the idea of explosion, the 2 objects initially they are at rest or the momentum is 0. But after they will actually move in opposite direction. So like rocket, right? Why is able to launch upward is because the gas coming up downward. So their magnitude is same. So example, this is for the rocket, and then this is the gas, or even like a rifle with a bullet. Yeah, so this is based on the principle of conservation of momentum, where they will have equal magnitude of momentum, but in opposite direction. So that's why when you want to explain how this rocket works, you have to explain in terms of how the gas is being produced first. And then you talk about the magnitude of the momentum. Okay, so this is how you say oxygen liquid and hydrogen liquid fill are burned in the combustion chamber. And the exhaust gas is ejected out of the rocket at high speed. And then hence produce a large backward momentum. And hence the rocket will gain a large momentum forward. And even though it's only 4 marks, right? So you can also mention about the concept of resultant force. Hence, the lift force produced is greater than the weight, hence it moves upwards. Yeah. Okay, then next. Diagram 9.2 shows a water rocket made from an empty 1.5 plastic bottle. By adding water and pressuring it with air for launching. Then you have 4 different models of rocket, P, Q, R, and S with different specification. So explain the suitability of each specification and then determine the most suitable water rocket and give reason for your choice. Okay, so as you can see, the specification is under what? They have the volume of water, and then they have the angle. Then they also mention about what? The pressure, air pressure, whether high or low. Okay, is it with plasticine or without, or additional material? So to answer this type of question first, you not necessarily must start off with a volume of water if you're not sure about the idea. So of course you want it to launch further. Okay, again, you should have high air pressure or lower air pressure. It's supposed to have high air pressure, correct? Why? So that when the water come out, or they are being forced to come out with high pressure, then you have a high backward momentum. And you can launch further, correct? Then next idea is the launching angle. Should it be 45 or 25? So what is the effect of this angle is basically it's 45, then will all have this projectile motion. Okay, while it is small angle, right, it cannot travel further. Yeah, or the best angle is exactly 45 degrees for it to travel the longest or furthest distance. If they are even bigger, let's say you have 60 degree, then it become like that. Yeah, so they want to be further, so the best angle is 45 then. Then what about the water? Why should we put some water? Because if there is no water at all, then the water is too light, okay? Yeah, hence it cannot produce a greater momentum forward. Okay, so the additional of water is to add on a little bit of weight. Okay, but then you cannot have too much water also, because too much water, the weight is too high or greater than the lift, right? Then it will also pull it downward. But you need some water inside. So the amount of water is normally about 1/3 lah, 1/3. So since the water is 1.5, correct? Yeah, so this 0.5 liter is the better choice compared to 1 liter. Okay, and lastly, it's supposed to have some plasticine on the part here. Why should you add some plasticine? Because you want it to move forward in a straight direction, or else it's too light, right? It will be shaking or wobble. It's just like you can add some fin so that they can move straight and forward. Yeah, so hence obviously we have all the choice on what for R. Yeah, so same thing for those question under making decision. The moment you choose correctly, you already have 6 out of 10 marks with the correct format of writing. Like you make a table and then you write like this way. So the launching angle is 45 degrees. Reason, produce the longest distance in the horizontal component of the rocket. Projectile motion. Volume of water is 0.5. Enable 2/3 of air is being filled into the bottle. Like I mentioned, the water is 1.5, right? And then you produce larger volume of pressurized gas. Then the air pressure is high, produce high momentum. The nose cone with plasticine enable the rocket to move in a straight line or increase the inertia of the rocket or stabilize the rocket. So lastly, you say what I is chosen as the launching angle is 45 degrees. The volume of water is 0.5 liter. Okay, air pressure is high and the nose cone is with plasticine. Yeah, like say, how do you get the 6 mark? When you have this point, this point, this point, ready, 4, 5, you say choose. Then you just repeat what you say over here, then you have mark 6. Yeah. Next calculation idea. Diagram 9.2 shows a bullet of mass 10 gram fired from a rifle of mass 1.5 kg. After firing, the bullet moved forward with a velocity of 250 meters per second, while the rifle recoiled with a velocity v. Determine the total momentum of the system before the shoot. Okay, that's mean before is the rifle move, the bullet move? No, they are not moving, right? So that's why total momentum should be 0. Then next, change the unit from 10 gram to SI unit. So the unit SI unit is kilogram. How do you change gram to kg? You divide 1,000. Lastly, how do you calculate part 3? So like just now, I derive out the formula when I explained about how the rocket is being launched, right? You have M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. But this whole part is 0, hence you have M1 V1 equals to negative M2 V2. You can straight away sub and get the answer lah. So assuming this is everything for rifle, you careful, you don't put the rifle mass, then the velocity of bullet then would be wrong lah. Then this one, everything will be for bullet. Then you just sub accordingly, and you supposedly to get the final answer as negative 1.67 meter per second. So you can have this negative is due to the recoil movement. That means the rifle will move in the opposite direction. Okay, so question 10. So for essay question 9 and 10, you choose one question. Okay, so diagram 10.1 shows a model of compact fluorescent lamp CFL and a model of a light emitting diode LED and the specification of both lamps. So what is the meaning of 240 volt 12 watt mentioned in the product details of the LED lamp? So again, this is voltage, this is the idea of power. So I always tell students change the idea of power become energy per time or joule per second idea. That means whenever you connect any device with those power rating, right, to 250 volt power supply, then the device will actually consume 12 joule energy every second. So this is how you write. The LED lamp consume 12 joule of electrical energy every 1 second, or 12 joule energy every 1 second when connected or supplied with the potential difference of 240 volt. Next, light emitting diode LED lamps have become the choice of consumer compared to the compact fluorescent lamp because they are more energy efficient and cost effective. Explain how light emitting lamp can save more energy and cost compared to compact fluorescent lamp. So basically, the way how they construct this LED and CFE is slightly different. And the main difference is basically always we have this input energy and also output. Okay, so for both LED, CFL, let's say you would to give the same amount of electrical energy, example, 10 joule, 10 joule. So the big difference is when come to output, most of the input energy is used to become light, which is useful energy. So they call it as output. But other than light, when you on the light, they also produce heat, right? Yeah, so that one is unwanted energy. So LED normally example, they become 9 joule, which is light. But then for CFL, maybe they only have 6 joule, but then the other 3 joule is become heat. So of course, this output is higher compared to the CFL. Then next thing is the efficiency. Efficiency is output over input 100% of LED is higher. Then their lifetime is also higher as well. So this is how you write. Also during the same period of use, LED lamp with a smaller power rating use less electricity. And generally when they construct this LED also, their power rating is actually smaller, which means they may only use like 10 watt, but CFL use 20 watt. Get the idea? To produce the same brightness as CFL lamp. And then smaller consumption of electrical energy, reducing the cost of energy consumption. And then LED light produce greater light output energy. This is what I explained than heat. And then less heat energy is produced by LED. And LED bulb are more efficient. Yeah, so all these terms you can use, but maximum 4 point out of all these 6. Okay, then next. Diagram 10.2 show a set of solar light emitting lamp. A sheep farmer plans to install solar light emitting diode lamp to light up his sheep pens area at night. And then again, you have 4 models, A, B, C, and D. So you are required to determine the model of solar LED light that can illuminate the entire area for a long period of time at night. And then explain the suitability of each specification and then determine the most suitable model of solar LED light and give reason for your choice. Okay, so of course, the solar lamp, the idea is you have the capacity to store charge, right? And then when you need it, you use it again, correct or not? So of course, the more you're able to store, the better it is. So among 8,000, 5,000, 10,000, 50,000, of course, 50,000, 10,000 is the best, And where should you locate your solar panel, the orientation? Of course, you should face the sun in the afternoon or in the morning when you will have the more sunlight during the noon, right? Yeah. Okay, you always do like that. And then the power rating. the higher the better, in the sense that you can emit more light, and the size should be bigger. So if you notice, even though here all write number, all this, so in essay question, you don't write number, you only write big or small. So example, this is the way I write: a capacity of the battery is large. Why? Can store more charges. Facing the sun at noon, receive high intensity of light. You see power rating is high. You didn't write the number, notice or not? Produce more light energy. Size of LED is large, so you can spreading light to a wider area. And then lastly, you say I choose D, as the capacity of battery is large, facing the sun at the noon, and the power rating is high, and the size of LED is large. Yeah, so this is the way how you all answer the 10 marks question for question 9 and also question 10. Okay, next, calculations. A fluorescent lamp is labeled 240 volt 32 watt. Calculate the current flowing through the lamp when light up with normal brightness. Okay, so this is voltage, this is power. So in order for you to find current, you normally will use this formula: P equals to VI, VIP. So I equals to P over V, 32 over 240, and you get the answer in terms of ampere. Then next, electrical energy that is supplied for 3 hours. Okay, there is a few formula for electrical energy, but the most common one is you get it from the formula for power. Power is rate of energy, right, dissipated. So you have E equals to PT, where you have this energy consumption idea. The higher the power, the more energy you use. The higher the time, same thing, you have use up more energy. So you just need to use 32 time with the time, 3 hours in second first. Yeah, then you will have the answer in joule. 3 times 3600. Then from joule, how do you change to kilojoule? Divide 1000. Okay, yeah, hence you will get this answer. Just now I show you already, 32 divided by 240. And then you use PT, yeah, hour to second, so you times 60 times 60. Just now teacher write 3600. And joule to kilojoule, you divide 1000. How come you need to change to kilojoule? This is what they expect. Okay, last question, question 11. Diagram 11.1a, a test tube filled with lead shoots floating upright in water of density 1 gram. And then 11.2, same test tube, but now they are floating in oil instead of water. Okay, so what is the concept involved? Archimedes principle. So this is under Form 5, Chapter 2, Archimedes principle. Okay, so same thing for question 11, there will be a 5 marks comparison question, similar like question 5 and also question 6. So again, I will say, this is compulsory answer. There's no choice. There's only one question. This part must try to answer, at least get 5 marks out of 20 marks minimum. Okay, so first, they want you to compare what? Density of liquid, depth of test tube, and also volume of liquid display. So oil and water, which one is denser? Of course, water is denser, or oil is less dense. That's why oil is always float on top of water, correct? Then the depth of test tube immerse. So this one immerse deeper, this one less. Then the volume of liquid displays, how you get this idea? This is the volume. So which one more volume is immersed? That means there will be how much the water that coming out as well. Get it? So that's why again it's 11.2. Okay, so you see density of water is higher, depth of test tube immersed in water is less, and then the volume of water displaced is less as well. Or vice versa, you can use another way. Okay, then move on. What is the relationship between density of liquid and the depth of the test tube immersed? And then make a deduction regarding the relationship between density of liquid and volume of liquid displaced. So first, they want you to relate density with depth. So the denser the water, or the depth of immerse is lesser, right? And then next, density and volume. The lesser the density or lower the density, the more the volume or liquid displaced. So this is how you write. Or vice versa, the higher the density, the less depth, the higher the density, the less volume. Okay, then move on. You have another idea on concept questions. So diagram 11.3 show a dropper made into a Cartesian diver and is floating in a plastic bottle filled with water. Describe what happened to the Cartesian diver when the plastic bottle is squeezed. Okay, so how does what is this Cartesian diver? Is basically you can make by a dropper or the pen cap. Okay, yes. You just need to add some weight and then make sure you can float upright. Okay, so how does it work is when you try to squeeze the bottle, right? What happens is the water will actually try to fill up. Okay, then it works like submarine. Why submarine able to sink is because they have ballast tank. They fill up with water, then they become heavy, right? So the weight is greater than the buoyant force, then they sink. So same idea. So the moment you squeeze, water falls in. Then they become heavy. The weight is greater than the buoyant force. Then they sink. Yeah. Okay, so here is how you give the answer lah. So when the water is squeezed, the water are forced to flow into the Cartesian diver. Then the total weight increases. And the total weight is more than the buoyant force. Then the resultant force is acting downward and the Cartesian diver accelerate downward or sink. Of course, any 4 point out of this 6 point, you will get full marks. Yeah. Okay, then last part. Cartesian diver in diagram 11.3 can be used to understand the working principle of an old submarine as shown in the diagram 11.4. Using appropriate physics concepts suggests modification that need to be done for the old submarine so it can dive to thousands of meters below the surface of ocean, able to rise and sink easily, navigate under the water safely, and remain underwater for several months. Okay, so for this idea, again, you need to construct a table. So you need to talk about how it can dive and rise back easily. Then how they can navigate, okay, see things clearly and remain for a few months. Okay, so you can talk about fuel that use there must be enough and then how they can sink and rises is due to the presence of ballast tank. And you can also talk about the shape of the submarine and then the body, all this. So you need to really think about more points in order for you to give the answer. And you can give more than 5 aspects for this type of questions. Okay, so here is the possible answer that you can give. The shape of the submarine should be streamlined. Why? To reduce water resistance. And then the special compartment installed with ballast tank, the water will be pumped in and up to vary the weight of the submarine. More numbers of ballast tank can increase the weight. And then the body of submarine are made by steel or titanium. So it's strong. So basically this viewpoint is similar lah. Just the way how you should write it off. And then the reason is to withstand the high pressure. And then the submarine also should be equipped with sonar system, estimate the distance to detect object underwater, or you must say the submarine also can attach with periscope. It's okay. Yeah, you can see object above. Then normally the fuel used in the submarine should be nuclear energy lah, because it can last longer and it's also cheap lah. Yeah, so this is a possible answer that you can give. So you can give more than 1, 2, 3, 4, 5. See, not here got 6, 7, 8. Yeah. Okay. As long as your answer is not contrast, then it's acceptable. What is meant by contrast? Mean you here say, there should be more number of ballast tank. Then later on you say, it should be only 1. So it's like you have 2 opposite answer. If not, normally they will minus your marks lah. If not related. Okay. So that's it for this Pahang paper. Hope that you all learned something. Thank you.